Hello, bonjour, and welcome to the Don't Waste Water podcast. I'm your host, Antoine Walter, and in today's episode, I am delighted to welcome Wim Audenaert as my guest. Wim is the CEO and co-founder of AM Team, a company named after the famous action-adventure television series. I'm sure you know that theme song. AM Teams offers leading-edge simulation services for process optimization and design. In this episode, Wim will explain why developing new water treatments the conventional way is unnecessarily slow and expensive, and what to do instead. He'll also explain why having a functional process that you don't understand is actually useless. He'll share us a simple trick that allows you to take the risk out of experimenting with your plant operations, and he will take us beyond today's capacities of process modeling to share a glimpse of the future. This and much more is on our agenda for today, right after our sponsor's word.
You're listening to Don't Waste Water, the podcast that helps water professionals to improve their wastewater treatment, optimize their operation costs, and keep up with the latest market trends. This podcast is brought to you by GF Piping Systems. As a leading supplier of piping systems made of plastics and metal, GF Piping Systems is the global expert for the safe and reliable transportation of water, chemicals, and gas. For more information, visit gfps.com.
So thanks for the intro, and thanks for welcoming me in my podcast. So it's kind of inception. I'm hosted by my host, but welcome, Wim. Welcome to the show. Actually, it's quite strange that our path didn't cross before, because you have been active in micropollutants treatment, so was I. You have been active in ozone treatment, so was I. You know people that I know as well, but it looks like for whatever reason, we had to cross a different way. And that's today the first time I see you in person. I have that feeling because I've been watching your videos, I've been reading your blogs, and I have the feeling I know you. And I think I have this little advantage on you that you don't know me. So welcome to the show, Wim. And maybe to start, for the people that might not know you yet, can you start maybe by pitching yourself and pitching your company?
Sure, Antoine. So first of all, I want to thank you actually for having this opportunity. I feel honored because I have seen who was in that podcast before. And these are very experienced people, very valuable for the water industry. So yeah, I'm honored to be here. It's a pleasure. But I will start introducing myself, of course. I'm Wim Audenaert. My main background is water and wastewater treatment technologies, mainly physical, chemical, and a lot of modeling. So modeling simulations has always been a very important part of my professional activities. I started my career at Ghent University. I had the ambition actually to become a professor, and it was really not far from that. In the meantime, in parallel, I also had entrepreneurial aspirations. And then I decided to co-found this company with some very nice colleagues 4 years ago in 2017. So our company, AM Team, the name comes from the A-Team. The A-Team is a special force team. It's a television series from the 80s. The American people will definitely know it. But we want to combine a very complementary people to deliver something that is extremely unique. So our company is highly specialized in simulations for the water industry. So we do computational fluid dynamics. We do multi-phase, 1, 2, 3 phase, 5 phases. We have a lot of projects where we add a lot of different solid classes, for example. We combine kinetics with CFD, computational fluid dynamics. We provide digital twins to our customers, or digital. I heard a very good name of that recently. It's like virtual twin. There are different names for that. And now we also offer a couple of other computational services. So we have 3 main customers, which are end users of processes, end users, for example, utilities, many utilities, but also large industrial customers with operating plants. Then we have consulting and engineering firms, but we also do a lot of work for technology companies. And this is very important because we help them. It is quite confidential typically, but we help them designing novel technologies, scaling them up, or improving their existing technologies. So it's quite revolutionary. We are a Belgian-based company. We have customers all over the world. So really a big fraction of our revenues come from outside Europe. US until New Zealand, Japan, so customers everywhere because of the niche focus. So that was my short introduction.
The niche focus is actually a nice transition because, I like to start with a simple question. What's your secret sauce? And there are many aspects in what you just said. Let me just let you answer this one. And then I give you my impression of what your special sauce is.
That would be interesting. I'm very curious, Antoine. Yeah, indeed. Well, I think our special sauces, but indeed, I think I should talk to the market maybe for that. I think our special sauce is that we are highly capable of performing the best simulations in the world, in our domain, in the thing what we do, combined with a deep understanding of the process side. If you do that, magic can happen. It means, for example, if you look at computational fluid dynamics, people generally look, oh yeah, you have a dead zone, you have some flow, it's hydraulics. But I don't call CFD as such a process simulation tool. You can also look at it from the process angle. You add the bubbles, you add the reactions, you do your simulations different because you understand how the process is working. This allows us to develop unique models that are globally unique, which allow really to do quite innovative stuff or to solve problems that were hard to solve before. I think that's our secret sauce. And then a second one, so this is the extremely advanced backend. I think we have really advanced stuff. We work in an advanced way. We have very good collaborations with also researchers, academic institutes. Our front end, I think, is very accessible for the customers. So we don't overcomplicate things to our customers. They often don't see how complex, how sophisticated our backend is. Because that's equally important. Otherwise, the market will never believe in it if you sell it way too complex. So I think that's our secret sauce, being very advanced, but not acting like that in front of the customers.
That's an interesting one. And I think that's probably a right one. Now I give you my impression. My impression is that your secret sauce is, another secret sauce is that you have a different approach. We live in a world, the water industry is a pretty conservative world, and you have a specific tone. You have a specific, I can feel the culture about AM team. Maybe it's an impression, but that's at least my impression. And I was wondering if you also feel that that's an important take in your success or in whatever you do, the way you approach it, the way that you show what you're doing in your communication, but also in the way that you present the people working with you.
Well, that's true, Antoine. So, the first part I was talking about, let's say that was our technical USP, unique selling point. We also have indeed our cultural USP. Indeed, we try to communicate very distinctively, quite in a unique way. The team is in our company name. The word team is in our company name. This is one of the core values we have. One of our values is also fun or having fun. So it means if you work with us as a customer, it means that you probably are getting energy out of this project, personal energy. If you're working for AM team, probably you also get a lot of energy out of your job. And in the end, as you also know, it's all about technology typically. Yeah? We are engineers, we look at the treatment, but it's people business, and this is the thing everywhere. How do you attract good people and especially keep the good people? By having a very good culture and not only talking about that, but really doing it. That's a big difference, right? Yeah,
it's about walk the talk. A last question in this first section before we dive into the serious stuff, but I've read your advice that you should not read 20 books and then apply them whenever you wish, but instead of that, you should write one book and strive to apply it day by day until you get it, and then you go to the next one. So I was just wondering, what's the book you are up to right now?
So I'm I call it parallel reading. So typically I read like 20 books in parallel. So that's a very difficult question. I cannot name all of these 20 ones, but I can say that I'm currently reading, for example, Crossing the Chasm. I don't know if you're familiar, but you're also have a very good commercial background. You will definitely know that book with the innovation curve. Why is that important for our company? Because we offer, some of our services are quite, I can call them quite disruptive. We have some lower barrier services, but some of them are quite new. And then you need to have a very good strategy to bring it to a rather conservative market, indeed. And then another book, I don't only, read business books. I'm, for example, reading the biography right now of the guy, Phil Knight. Phil Knight, the founder of Nike. how he founded his company, getting some shoes from Japan, selling them in the US. It's so inspirational. It's like every of these big, huge companies are born like that. I'm looking up to them. So I'm reading biographies, history, economics, psychology. A good psychology book I'm currently reading is, Charles Munger. That's the business partner of Warren Buffett. Yeah, he has a very good book. That's Poor Charlie's Almanac. That's a Bible for me. Wow. It's huge, but it contains so much wisdom.
The best I can wish you is to follow the path of the founder of Nike, because when I read that book, I was pretty amazed, because when you think of Nike, it's like you think that company has been around for 2 centuries. It's so big. It's so everybody knows it's like one of those worldwide companies. And when you read the book, just recall that, they started small as well, and they might have died every second for years. It's pretty inspiring, I would say.
It is. Another one is Sam Walton's biography of the founder of Walmart. Same story. Very inspiring.
So there's kind of a pattern. So I hope for you that you follow the same pattern, because you are the one founding a company. I'm not. So thanks for those advices. I have to say, I have new books on my reading list, thanks to you. If it's fine with you, I propose to dive to our deep dive of today. And what I was pretty intrigued in what you are publishing is how you can remove all those steps which are pretty common in the water industry. What I mean by that is that, and I had people on that microphone on that podcast explaining me what's their go-to market, how you start from a very process idea that moves to a pilot, then the pilot goes to a small scale, eventually to a middle scale, to a first full scale, and then everybody's watching for 5 to 10 years if that thing might be burning or working at all. And then if you can prove yourself to have 1 reference, then somewhere down the line you get 5, and from the 5 you can get 30 and so far and so on. Then you have people in the industry which start talking about the digital twin and the way that the digital twin can be a clever way to run many modelization of your plant to be sure that you are running the best process at the right time. And actually, that's what I discussed with my last guest on this podcast. But you take it even to the next step. You are building the digital twin to a plant that doesn't exist. So the plant is fully digital, and only once it's fully designed digitally, you say that's the process, which is the right one, and that's the one that we can build. So I'd like to deconstruct that and start from the beginning of your process and go step by step. So what would be the first step for that?
Well, I love this topic because it has become such an important topic in our company. I mean, if we look at our services, this is the service what we call virtual piloting. So we have a service that we name virtual piloting. The name itself says that, okay, let's pilot on a computer instead of in reality. It's quite indeed new. Huh? People call it digital twins, or I heard 2 days ago, we were having a discussion with some people from IWA, my co-founder Ingmar Nopens, and then Dragan Savic from KWR. He was actually saying, yeah, everybody has his own definition of digital twins. You can call it virtual clone, whatever. But the thing is, I will walk you through. So if you develop a new process, you have actually 2 big parts, 2 big objectives. People don't see these 2 objectives. They only see one. Let's make a technology that works. You have 2 objectives. The first one is more of scientific nature. Let's figure out the process, and let's also determine the optimal conditions for the process to work. When that is done, you actually build a reactor system to host that process. In my opinion, a reactor or a system is nothing else than just a vehicle to get to your goal. So a process as such cannot work. That's why you put it in a design, in a reactor. The skills you need to develop the process, to do the testing, and to do the reactor design, and then to scale it up to a successful full-scale plant or installation, they are so different. Usually the same people work on that throughout the whole period of time. My impression is that it would be good to work with different skills there and to blend in computational fluid dynamics from the early start. So what do I mean with this? Not making this distinction, people will then build indeed, okay, our process works, let's build a small pilot. Usually, they build a pilot for 2 reasons. They want to test the process in real conditions, and also they want to tweak the design of the reactor. They want to start tweaking it. They want to start optimizing the process. If you ask me, the second one should be isolated and should be completely virtual. Completely virtual. Why? Because I have literally seen people building a unit of like meters of height, stainless steel. It's a reactor of that costs also operating it, measuring, sampling hundreds of thousands of euros easily. And then it doesn't work. They manually open it. They start changing the design. Suddenly it works. They don't know why. So if you don't know why, you are not learning. If you then make a scale up again to a larger scale, you have no principles where you can base yourself on. So you can start from scratch. Why do I say that you can start from scratch? Because scaling up is the most difficult exercise. I always say to my customers, water molecules or gas molecules, unfortunately, they don't scale along with the reactor. They remain the same size. If your molecules don't scale with your system, which you are scaling, you have a non-linear behavior. And it costs huge amounts of money, but I mean, the time spent is years. What if you can cut this process with like a few years? Your technology goes to the market way earlier. It is quite disruptive. If you ask me, it's hard to stop because it works so brilliantly that the benefits are just huge. I mean, people that are now like doubting it, I think they will one day just start doing it. So that's what I call the virtual piloting. You will accelerate the development of a technology by isolating the design. So let CFD be used for the design. Of course, we use very realistic CFD models. We include all the process phenomena that we think are important. I mean, you have a virtual clone of your process that is extremely realistic. And if it's very realistic, you can use it.
To start really from the roots for the beginners, for the stupid like me, what do you need at the beginning to feed your model? I guess you still need to have some kind of physical stuff. So water analysis, water samples, what's the root?
Yeah. So if people are developing a technology and they call us or they email us, typically what they have, if you're in development stage, you have a small scale system that works. That typically is happening either in a lab or a small pilot on site. We have seen both. And then they ask the question, we have to scale this up 1 or 2 orders of magnitude. Well, first, we will start modeling this small scale installation. Because it's a test installation, they have a lot of data on that. Measurement data, flow, everything is very well monitored because it's an experimental setup. So we need some flow rate data and some water characteristics, for example. Of course, some operational data like flow rates of air as well. And then the design, not in a digital file, but some clients just draw the dimensions on a paper in order that we can make a 3D design. Then we bring in the physical equations and we start. So actually it's 2 things, input from the process side, which is actually readily available, and then the design input.
The lab or the pilot version of it is already working. It's a process which works to treat a small amount of water and you're scaling up. But can it happen that on that scale already, there are still open questions on the process?
Well, there can be open questions indeed. Some of our customers could not explain a certain behavior of a technology. I mean, for example, the oxygen transfer rate was way lower than expected, or the conversion rates were lower than expected, and they couldn't really grasp it. If you then perform an analysis at that scale, we have had quite some situations where you really see the problem. And of course, the eyes open. Huh? I mean, oh man, this is the cause, of course. Yeah. But once you have done that, so we typically develop a very good model there. It takes some weeks. I'm not talking about a year, because that's also a misconception. CFD cannot be used. It takes months. We finish projects within weeks. Of course, large and big scale-up projects, they go over months because you need discussion with the customer. But I mean, once you have done that, we scale up without any intermediate piloting. We start going and we scale up this reactor with 1 or 2 orders of magnitude. Typically, the first prototype looks not so good. I mean, the virtual prototype. And then we make 4 or 5 new ones. And there's always one that is really, we iteratively work. Huh? So you see the problems coming, we change. And you end up with a system that you don't only understand very well, you know why it works. The system is the best one. It's not like a compromise. on design.
So when you say it's the best one, how can you assess that it's the best one? Are you running multiple hypotheses in parallel and then choosing, like Darwinism, taking the best one?
Exactly. For example, in one system, the inlet-outlet configuration can be slightly different. Maybe the water level is altered, or maybe the height of some baffles or membranes or whatever is in there, we change. And some of these perform best indeed. Of course, can you keep optimizing it incrementally? I'm pretty sure. But why do I say the best? If you would have not taken the virtual route, you would have never known what design would have been the best. Maybe there was still an improvement, significant improvement possible.
I think that's the story of water treatment. If you look at it, I think there's no two plants which are really identical, because you always identify something which would have been better. And what develops over 30 years or 50 years, if I get you right, on your scale, it's more a matter of weeks, because you can evolve the model and have much more iterations than on a concrete tank.
Exactly. Well, yeah.
So when you say you model something, how can I understand that? Again, don't forget I'm stupid. When you're modeling, for instance, let's say an MBBR, there's the MBBR from one supplier, and then there's the MBBR from another supplier. If you listen to them, they're going to explain you how different those two designs are and how different everything they do and the process is, because it's not the same chip inside, because it's not the same overall design. And some of them might be proprietary and some others might be just common design that everybody is doing the same. How do you address that? Does that mean that you have, let's give 3 names so that I don't have only one, but do you have one design for Veolia, one design for Suez, and one design for Vabag? Or do you have one thing which is called an MBBR?
Yes, I would say we have one thing that is called an MBBR. We have the model in place that can model a MBBR. So it means water, air, and these very difficult to model solid granules. So we have constructed a model that is based on physics that is actually applicable for many designs. So typically what we do is we are approached by people either designing a new MBBR, or we are working together with people that are developing these in-house technologies, these technology vendors of MBBRs indeed. I'm just giving examples. So we don't really, there are many people very good at selecting technologies, I think, on the market. We don't want to replace engineering and consulting firms that put together treatment trains. What we want to do is we add something that nobody has to really optimize the design. So I would say it's a generic framework. Of course, if we work for technology companies on a core technology, on a brand name, but that's very under the radar. It's all confidential. We cannot really say a lot about that.
So you've mentioned the technical aspect of things, which is finding the right process and seeing how that might scale up. You've mentioned in the introduction the human aspect of things, but what about the economical part? Because sometimes the best process might be technically the best, but might be also the most expensive. And then if you compromise maybe on 5-10 person treatment capacity, you might have something which is much better in terms of money. And then there's a subjective part. How do you weight economics against techniques? Is it something which is within your reach, or is it something that you leave up to the end user or to the engineering consultant?
I would say the major decision there is taken by the end user and the consultants, indeed, because they are doing this as jobs right now. What we, of course, offer is, if it really comes down to operational cost or design cost, of course, we can assess if you can maybe make a reactor 20% smaller for that specific process here. I'm just talking about ozonation. We have done a huge amount of work on that. I also did my PhD on that topic. It's close to my heart, but that process has so many opportunities to improve. So you can both reduce CAPEX and OPEX significantly by doing this kind of modeling. And then, of course, if you then make the comparison with the technologies, it can impact your decision. But typically, we are really a company that works together with a lot of parties. We are not like a very big consulting engineering firm that does all these things together. We try to really focus what we are very good at and then work together with the parties that are good at other things.
So typically on a project, you're there for the process. There's a manufacturer which is there for the equipment itself, probably a consultant and end user. And that's the winning team, if I get you.
Yeah, exactly. That's a good winning team.
Actually, I'm too tempted. Sorry, I have to dive in this one. You're an expert in ozonation. I recall from my years when I was working in this domain, we were running a pilot on the removal of micropollutants, and we had a pre-ozonation. So you have raw wastewater, you put ozone inside, and on the paper and all your wisdom and all the scientific papers, everything tells you that this has no chance to work because your ozone is going to target everything but the micropollutants. And indeed, we had a significant reduction of the micropollutants through this pre-ozonation. And as you said, I think we had something working, but we had no clue why. And then you cannot industrialize it, because if you have no clue why, then you cannot upscale, you cannot consistently take warranty or say to someone it's going to work, because if yourself, you cannot explain it, then how could you sell that? Is it the kind of thing, the kind of riddle that you can take on and say, hey, by the way, there's a way to model that, and the model might tell us what's exactly happening?
Yes, Antoine, my answer is yes. We have been working on a mechanistic kinetic model for the last 4 years. So now it's really like in a very advanced stage. It's in the application stage. And this model contains mechanisms. So it means if you start modeling that process, you know which micropollutants are being removed, how many hydroxyl radicals you have, how much ozone you have, and which part of the removal is caused by the radicals and by the ozone for each of the individual components. I can say, of course, in raw wastewater, you will not have any measurable ozone, but it has been there, right? So you have had an exposure. You added, for example, 10 milligrams per liter. You added 10 milligrams per liter. It's not there anymore, but it reacted. So you had an exposure. The exposure indeed can be more than sufficient to remove some of the pollutants very easily. And it might lead to a huge amount of radicals. Yeah, given the organics, the organic matrix. Ozone will start stealing electrons from the carbon molecules. It steals them. It will produce extra hydroxyl radicals.
So model you're mentioning is Amazon, right?
Exactly. That's Amazon. So Amazon.
Oh, now that you say it, I get the pun. It's funny because I saw it written, but I never got it. Yeah, okay.
Amazon, yeah. It's a brand of
I'm
AMT.
really stupid. Let me pat myself. So let's take this one as an example. How do you come with such a model? What are the steps to develop such a model?
Yeah. That's another good question, Antoine. You're a very good interviewer, I think. You have to start simple. That is the main rule, I think, for any modeling. Don't start overly complex. And that is a big risk for scientists that know too much about the process. They will only see what is not in the model. An engineer looks at it from the practical side and just puts up some first equations. I strongly believe in the Pareto principle. Try to create the first 20% that gives you 80% of the value. I really believe in this for modeling because, yeah, you can keep extending, but I really believe that with a few equations, what are these equations? These are the key principles of this process. You have to, of course, know some of the process to derive the key principles. One of the key principles in ozonation is, for example, don't build a model that only has ozone in it, because you will not be able to predict any of the pollutants that react with hydroxyl radicals, right? Bromate is formed by both ozone and hydroxyl radicals. So you simply need both in your model in order to accurately predict bromate. So these are, for example, some principles in ozonation. So you isolate these principles and then you have to, I think, build a few equations around these core principles and take it from there. It gives so much motivation because you can already start calibrating your model. You see the data being described. And of course, then you can make it gradually more sophisticated. I think that's a very good exercise. If you start overly complex, you might really get disappointed.
So maybe what you're saying is the Google approach. It's this iterative thing that you have to first put something which has two legs and that's pretty it. And then from that, you build the details until it really describes what you see. And once it describes what you see, you get a fair understanding of what's happening.
Exactly. That's true.
Okay. So that's what you did with your ozone modeling, but you expanded far beyond the ozone with your company. So do you have to build this kind of model for each kind of treatment? And if yes, of course, there are thousands of treatments. So you are busy for the next century if you have to describe everything.
Well, the good news is that a lot of very beautiful models have been developed by a very, very knowledgeable people in our industry. I'm just talking about nitrification, denitrification, phosphorus, secondary settling. There are really many, many things described. So if we can use an existing kinetic model, we can readily plug it in our CFD model, and we can really use it. Of course, you have to implement it, but that's what we regularly do. If we have a very big question from a customer, and we also think that a lot of other customers will face this question, then we start developing an own model. We are not really scared of that. So our company is also spending quite some effort on R&D. Only, of course, if we have looked at the market, we will not tailor for every customer one model that we can use once. But we will try to look at the market, how big is this need and this problem? And then we start going. For the ozonation model, it was clearly the case, clearly.
Well, actually, for ozonation, I can only subscribe to what you say, because it has been for years this big debate, bromate, when is it at risk, when not? Should the wastewater be treated to the drinking water levels? And then the bromate, of course, is even more of a problem. And if you're solving the problem of micropollutants at the cost of creating bromate, of course, you are just replacing a sickness by a sickness which is even worse. So I think there you're bringing clarity, or at least in my eyes, you're bringing clarity. But to me, the interesting aspect is that what you're applying at the beginning allows you to scale up from a lab process to the operation, so to the full scale. But is that the end of the road? Or do you have then next steps to say, now, okay, we have designed something, it's working, but there's always room for improvement? Is it something that you leave to the operator, or do you still support them? And is it also inside your reach?
Exactly, Antoine. It is within our reach, because we have touched upon so far in this podcast on the development of a technology. Okay, then you might select technology on your plant. Will I select technology A, B, or C? Okay, let's go for C. Then you design it. For example, you use CFD to design this plant, a very good reactor, no short circuiting. I mean, it's always working fine. Okay, it has been built. Then the operation and monitoring starts, of course. Well, we have a lot of customers that come to us then in that stage. We have the CFD model anyway. We have an in-house methodology to export that CFD model to a very simple process model that runs in any simulator. I know, for example, you had Imre Takachi on the podcast. So you can run that, for example, in Sumo. The big drawback of only process models in quite complex hydraulic systems is that they have to assume mixing conditions. They have to assume a complete mixing in a large chunk of the basin or reactor. In reality, it's not happening. So what happens is, if they neglect the hydraulics, still they get good fits on their data if they tweak the parameters, but they will have to tweak them from time to time. And actually, they are tweaking kinetic parameters to compensate for a missing hydraulic description in the model. So what we can do is we can derive from CFD simulations an extremely simple but very, very accurate hydraulic model that can contain the kinetics as well. We call that a very realistic digital twin, and that can be running in parallel with the plant. So that is the link, I think, very easily to the operation. We had one other customer where we had the virtual scale-up, so the virtual piloting. We delivered a full-scale installation that was the final one. They build it. We again transform this model to a very simple process model. And our customer has a process model he or she can play with themselves. For example, for customer A, this water matrix comes in. How would our technology perform? Customer B in our technology, this effluent, how would that perform? They don't have to pilot this. They will run it through this flow sheet model. It can run in offline or online. Offline for testing different conditions. Online to create really the digital twin. So that's the link.
That triggers two questions for me. The first is, when you have those kind of processes, if you're running it, I get it, you build the process so you understand what's behind. I'm pretty sure you would see if something isn't realistic or doesn't make sense. I mean, you've probably must be 1,000 times better modeler than I have ever been. But when I was in engineering school, we had models. We were running models, and then we had water 2 meters high, and then there was no wall, but still the water was not flowing out, and we didn't notice it. So that doesn't happen in reality. So if you don't check, of course, you just take results for granted, which are not granted. So you have that knowledge, but I'm not sure every operator has that knowledge. So maybe you might have to have a watch on that. And my second question is, while we're at it, why wouldn't you take the opportunity to automate aspects of the plant? Because sometimes the model might be a better operator than the operator himself.
Well, that's indeed a very lively discussion going on in the whole water industry right now. The digitalization. Where are we going? I completely believe that you can automate a large, if not complete parts of treatment processes. The question only is, when will this happen and which part of the process first? Probably the most simple ones that we know most of it. And so it means our models are most trustworthy. So probably those first ones, because the model you need in order to do that needs to be very good, of course. But then indeed, the benefit of such a model is that it looks in an integrated view. And an operator has much more difficulties to see in an integrated view what's happening. Coming back to the ozonation, one example is we did a study for WEFTEC, actually together with Dynamita, HRSD in the US, and then Jacobs, a couple of people. They had a very nice biological treatment plant model. We had the tertiary ozonation model. We coupled them together. What they did is they optimized the sensors to tweak the controls as such that the effluent was more suited to be treated with ozone. What does this mean? Lower nitrites, looking at ammonia, for example. If you combine the whole train with models, you know how an upstream decision will impact a downstream process. And that is probably the main reason why you might be able to make better decisions. One of them probably, indeed.
So really having a full plant approach against something which is really saying, I optimize this one, optimize this one, optimize this one, but then you end up with ozone scavengers in the ozonation. And then, of course, the ozonation gets inefficient. So you run in the most efficient way something which cannot be that efficient because of what's before. That's an interesting one. Which brings me to something else, which is, you can digitize many things. And one of the things you can digitize, if I get it right, is the sensors. So you take some simple parameters and you put some digital sensors which are taking your advanced parameters. And then we have been using those advanced parameters for years as a proxy to measure things which we could not measure. If I go back to the micropollutants, we say you don't need to measure micropollutants because if you measure COD, then you're also measuring the micropollutants. But now we can also say if I measure pH, flow, and conductivity, my model might be able to give me the COD. So I would be measuring very, very simple things. My model calculates something which is a proxy to something. So now it's a box in a box. Is there at some point a limit to what we can do with the models? Or really, that's almost magic?
Yeah, interesting. I think you can do a lot. And of course, mechanistic models have their limits. Why? Because if you look at wastewater treatment, by the way, we work both in drinking water treatment and wastewater treatment, our company. I love this because there is such a gap in between these two worlds. We really try to bridge this. But apart from that discussion, wastewater matrix is much more complex than a drinking water matrix. It's so complex and variable that it's very hard to know everything in your mechanistic model. I mean, the inputs, extra equations, extra variables. But we have AI coming, and I strongly believe in that. I think it has huge potential. And these models can collaborate. Imagine you cannot explain part with your mechanistic model. Why not try to fill the black box with your AI model? AI can do stuff we don't grasp with our brains. We don't know how AI does it, but it produces a certain output that is valuable. Of course, the question is again, when will this happen? But I strongly believe in AI being capable of bringing us a lot of value in that respect.
I am a digital enthusiast, and I was told many times that I'm probably too enthusiastic. So for once, I'm going to take the other end of the scope, and I'm going to give you my Star Wars example. In Star Wars, Luke Skywalker is flying over the Death Star, and he wants to destroy the Death Star, and AI cannot find a way to do that. But suddenly, he just disconnects the AI, and he feels the Force, and the Force allows him to destroy the Death Star. So I'm pretty sure that Star Wars is fiction, pretty sure. But for a second, let's look at that one. The operator has his gut feeling, and the guy in the lab developing the process has also his gut feeling, and this kind of magic, and this kind of, this apple which falls on Newton's head, and then he discovers gravity. Sometimes there's the beauty of the unforeseen. Is it something which might be disappearing if we rely solely on AI and solely on modeling? And if it disappears, is it a bad thing?
Yeah, if it will be disappearing, or how to say, if it will become obsolete, I don't really know. All I can say is that you have people with 20, 30 years of experience, 40 years of experience. They sense things that nobody can sense. I also believe in that. For example, they go to a plant, they look at the bioreactor, they look how the swirls of the sludge go, and they know if it's well settleable sludge or not, based on the patterns. Because, if it's well settleable, you will have some clear zones where there's some less mixing very easily, for example. They combine all these observations from the past. They have kind of models in their heads. It's actually also a model, but it's a human model. The only problem is that the principles are not written down. So if these people retire, that's the problem. That's the benefit of a model. It's a database. It's a storage of principles. And I think they go hand in hand. You cannot underestimate experience from people on site. These people can be of great help, I think, in improving models. They look at the output and they will know if it makes sense or not. They will know. If it doesn't make sense, they will very rapidly lose the belief in the models. If the model shows something that they were suspecting but could not measure, they become overly enthusiastic. I think both go very well together. How it will turn out in the long term, let's see. I don't know. But experience is so important. And this is what brings us to the process understanding. If you are a good modeler understands the process side. Why? If you are only looking at your model and you don't understand the process, you don't know where the weaknesses are, or you don't know which additions potentially could add value. Where is the uncertainty? These are, again, the big principles of the processes. I think modelers have to have a good level of process knowledge and then talk a lot with the people on site and people that have designed so many plans before and things like that.
So that speaks for your secret sauce, basically. You cannot be just a software designer. You have to be a modeler on one end, of course, but you need to have that process expertise, because if things don't appear to be the way they should, you have to notice it, and your gut feeling has to help you on that. By the way, you addressed it, so I'm going to ask you this difficult question. I know it's almost impossible to answer, but still, I'd like to have your take. If you're looking in my crystal ball and you're looking into the future, let's say 2 years, 5 years from now, is modeling now the new thing everybody is doing? Is it still something which is relying on specialists like you, maybe a bit more people, maybe your company is even twice bigger by then, or 5 times bigger, or the new Nike? I wish you all the best. But what's your vision?
Well, I think my vision on that is, in the end, if you look at the big trends from history, the new ideas always start with a small group of people. I mean, the specialists able to understand and daring to take the risk to struggle using this new technology or whatever you call it. And then throughout time, it reaches the big chunk of the market and more things get, I call it, commoditized. So I strongly believe in the fact that things we only can do today, that within 10 years, much more people will be doing it. And they will need much less specific knowledge on modeling. Because look at the simulators, they have become so accessible, many of them. For example, many people, they are not really modelers, but they can use these simulators for treatment plans. They are so easy, straightforward, graphs. This has already become much more accessible. It will happen for CFD as well, I think, for many of the applications. The simple ones first, of course. But in the end, I strongly believe that more and more people will start using it. On the other hand, there is like another parallel thing I like very much. Our society becomes very specialized. So we are living in the world of being very specialized. You can build a company on a niche of a sub-niche of a niche. You can build a successful company on that because you are simply the best in that little micro niche. So on the other hand, if you outsource work to that company, there is probably high likelihood they can deliver at a tremendous speed and a quality you can never meet. So probably to answer your question, we have to distinguish between what is your goal, what do you want to reach, Is it something you should be doing in-house? For example, everybody can try building a website, but how many companies do build a website in-house? There are so many platforms openly accessible. We are outsourcing our website. It's not our core activity. So I think if it's important enough to be your core activity, more and more people will start doing it in-house. But still, then there will be a lot of big part of the market where they can do it potentially, but it's not their core business because they can do everything if they want to. And they will probably start outsourcing to specialists. So the objective is very important. Also, is the model existing or not? How mature is it? Do you need a lot of experience to handle it?
And so specifically on your company, on AM team, where do you see yourself in 2 years, in 5 years?
You mean in company growth or?
In company growth and company both, it's the season. All the companies are buying themselves together. So maybe that's also a way to see it. I'm joking, but I like to see what's in the crystal ball.
Yeah, we were joking with our team here last week. Oh man, we had plans to buy Suez. Damn. Veolia did it. Damn. Now we will have to save for a couple of years to buy the whole thing. So that was our joke. But our company, well, we have big ambitions. Why? Because we feel we can help so many people globally. Too many people to stay small. So this means we want to keep growing. I think hiring will never stop anymore. Now in our company, we will hire regularly new people. So within 2 years, I expect this company to be like 30, 35 people. We are now with a team of 11 people. And I expect within 5 years, our team size around 80, 85, something like that. And within 5 years, we would really love to be the reference internationally. If you need that kind of stuff, go with the M team, right? It's like a no-brainer. That should be the goal within 5 years internationally.
I'm sorry, because I have to be cautious of your time as well, but there's still one aspect which is really puzzling me, I have to say. Maybe I was not watching, but when I was working for a big company, to me, the water world was a world of big companies. And over the last, I would say 1 to 2 years, I see many startups, really interesting takes on that market. And I don't know if I was not watching or if really that's a trend out there that more and more people have ideas to nail a niche because there are many, many specialized aspects that you could do as you are the absolute specialist in your absolute field. Is it your same impression that it's growing, or was I just not watching enough?
Well, I also cannot really quantitatively judge, but I have the same impression. I think, probably the water industry became much more sexy. Some of the utilities have done also great jobs in that to make it extremely there are some utilities worldwide. Some of them you look up to these people, which vision they put in the field. So that is changing. It has become more sexy. On the other hand, of course, you have all these things, climate change, water scarcity. Even in Belgium, where it's raining a lot, we have drought. It's much more on the agenda of the politics, and gradually it would be much more on the agenda of investors, probably, if not already. So probably there is a more interesting ecosystem that might drive all of this. I have written it down on my notes. Start your business in the water industry! ! So I think it's a good moment to start specializing as long as you're unique.
Right. You mean the world doesn't need an additional marketing company? It really needs water treatment people. No, I'm being sarcastic, but but it's true that it's a field where you're less tempted. I have to say, when I was in school, it never crossed my mind. I never thought, wow, I might create my company. And it's quite inspiring to see people like you or other of my former guests on the podcast, which just went out and say, hey, I have a different take on that industry and I can do something. And I think it's inspiring. So I hope it inspires some more people.
Exactly, Antoine. And it's closer than you think. I did a post on this like a few weeks ago on LinkedIn. It's closer than you think. Because before starting your business, you are thinking like, oh, it's so big and where should I start? Start small with the right customers and you will get there. If you are really indeed think about what makes me very unique and you occupy this little niche, every vacuum has to be filled. That's a physical principle. And if the market grows and changes so fast, you create much more vacuums than the people can fill them. I think there are great business opportunities, great ones. I think coming back to the investments and economics of water industry, there's definitely a paper, I read it on LinkedIn. It was Sudhir Murthy. He co-authored that paper with 3 other authors. It's published in the Inter-American Development Bank. It's called Innovations in Commercial Finance for the Water and Sanitation Sector. It's out of your comfort zone if you're a technologist, but I would recommend reading it. It's really summing up the barriers for investments in the water industry. One of the barriers is that you have very high capital requirements and low tariffs. So there's not really an economy in water. I mean, this infrastructure is there. It's aging for 20, 30 years. Challenging governance, complexity of projects, and a lack of data in payback times and things like that. But I think they do great effort because you can work on the technology side and create all these beautiful things. But if there is no economy supporting it, and I'm especially looking at many of the countries that still have to build the main infrastructure, well, then you have a problem. So that should be there as well.
So I put the link in the episode notes for the recorded version of that podcast. Wim, at the end of all of my interview, I always concluding with the rapid fire questions. So if it's fine with you, I propose you to switch to those ones. It's supposed to be short questions, short answers, but don't feel yourself restricted if you have interesting stuff to say.
It's time for the rapid fire questions.
My first question is, what is the most exciting project you've been working on and why?
Yeah, well, we have been working on a lot of them, but I would say my most exciting until now is the development of the novel ozonation model. Because there are so many aspects that make it very attractive to me. Great partners, vision, daring to do something that nobody thinks is possible, and then applying it and making an economic business model around that. I mean, we have great partners there, Dynamita, HRSD in the US, and us. We started this rolling this ball, so little by little, and it grew. And I think that's my number one experience. My personal, our team has so many cool projects.
So what's your favorite part of your current job? And that might be difficult because if I get you right, you tend to love everything about your job. But what's your favorite part?
I have thought about it and prepared this question a bit. But I think it's creating, to call it in CFD terms, creating a bit of turbulence in the market and also energizing people at the international scale. I think that's really what gives me so much energy. I mean, that's the benefit. Also working in a rather slow, if you call it that way, or conservative industry, there are so many opportunities.
What is the trend to watch out in our conservative water industry?
I defined several trends. I've written them down here. For example, there are many societal pressures. For example, regulation, climate change, things like that. Water reuse, water scarcity. But then you also have technological trends. And if I can just isolate one, I think the main things to watch are not per se new disruptive treatment technologies. There will be, of course, but I think it will rather be a platform. For example, VR, AI, these kind of platforms, how they will be integrated in the water industry. I think that's something to watch. And if you ask me, big opportunity, a lack of companies that can, one, provide value, second, explain the value to the market in clear, understandable words. Huge opportunities if you ask me to start a company.
You say AI as a platform, but is it a platform for the water industry or is it a platform which is broader than the water industry? Because maybe you have some data from the energy sector or data from the transportation sector and you could leverage those and have a better take on the networks. And if you have a better take on the networks, then you have a better take on the water and so far and so on. It's an integrated cycle, isn't it?
Yeah, exactly. So indeed, probably a lot of inspiration can be indeed taken from different industries where it's already much more mature. One example is CFD. CFD is not new. We didn't invent it as a company. It existed in the 70s, in the 60s. They use it in aerospace, car engineering. Not a single car is designed without CFD, not a single one. But that's already, decades that people use it. So I think you can steal things from other industries. It's extremely powerful. And that's why reading multidisciplinary is also very valuable. Read different books.
But I guess not everybody has the ability to read 20 books in parallel. So
No.
There's a limit to some brains,
Well, you have to be a bit of a freak also. I think some people will think I'm crazy, but I don't mind. I'm enjoying.
What is the thing you care the most when you're designing a new process or a new product or a new service? And what is the one you care the less?
I like that question very much, actually. I have written down care most if we can identify a big pain in the market we can put a solution against that. So we can cure that pain, that big pain in the market. And we are the only company able to do that. That is what I care most about if we start up new ventures or projects. And care less, I think at least it's money, I would say, in a development stage. What I mean with this, of course, you have to be careful that your account doesn't dry up. But what I mean is, if you are developing something disruptive or quite new, or you have a research project going on and you really believe in this idea, speed is much more important than money. We always leave some dollars or euros on the table, I think, in projects that are in the framework of a development effort. We could squeeze these projects slightly more, but I don't want to lose one more week in a negotiation.
Now that you're mentioning money, I was listening to your interview in the podcast from Akim El Fadil, which was a very good podcast and very good interview from yourself. And you were mentioning that you didn't have any accountant. Did that change since the podcast because you grew, or are you now watching the finance as well?
Yeah, we have always had an accountant, actually. What I think I said in that podcast is that I was still doing the administration. I was the one sending the invoices to customers, following up the payments. This has changed, I can tell you. Yeah, we have a very good colleague, Veerle. Man, that is a revolution. I mean, and that's the biggest challenge for growing a company, huh? Delegation. You start with like a very mixed thing of tasks. You don't know even in which category they belong. And suddenly you have to isolate them, delegate them to one person. Isolate them, have confidence in the person, isolate. It's incredible. It's a very complex exercise. But that one was one of the best decisions, delegating that one.
So that's a good advice, I think, for the entrepreneur wannabe that might be listening. Yep.
Exactly. By the way, Antoine, we are a modeling company. So it means we have a financial model that predicts our cash flow, of course. I love that model because we calibrate it, we have some data, and then suddenly, yeah, of course, the next quarters, you have no predictions. And I mean, the model is really cool to predict.
That's a good one. Do you have sources to recommend to keep up with the water and wastewater markets? I'm going to do a bit of your advertising because I guess you're going to do it as well. I've seen that you're enrolled for WebTech Connect and that you shared your recording. So I'm looking forward to your presentations at WebTech Connect, but I stopped answering my own questions and I'll let you answer it.
Thank you, Antoine. I'm glad one person will look at my presentation. Really glad to hear that. And then, yes, I have written down a couple of things. I think the first thing is the paper I already mentioned, co-authored by Sudhir Murthy and some other people by the Inter-American Development Bank. So on the innovations in commercial finance for the water and sanitation sector. To me, I love it. I will reread it. It's quite heavy. But then I would recommend a book that every water practitioner should read. It is called The Quest for Pure Water, The History of Water Purification. The first name of the person of one of the authors is Moses, but I don't remember the last names. But you will definitely find it. It's a blue cover. I love it because, I mean, there you see that water treatment started, millennia before Christ. It's so cool to see all these development and the questions. And then, so that's certainly a source I would recommend. And I like to read history to understand the future. I love this. Why? Because again, it's about principles. Things happen over and over and over again. So if you read a lot of history, you become much better at predicting the future, I think, because things repeat. And then events or networks that are definitely interesting to follow, to keep up with everything. I think it's WEF, Water Environment Federation, IWA, International Water Association, IOL Utilities. It's a great platform for young companies to showcase what they are doing. Global Water Intelligence, Blue Tech. I think all these platforms are doing great efforts to make this world a better place.
So I arrived at my very last question. If you had to recommend someone to interview in that podcast, who would it be?
Well, I have a person in mind, yeah. But I don't know if you will be able to catch him for this podcast. I don't know, because he might not like it. I don't know, but he's definitely worth interviewing. It's Charles Bott. Charles Bott is CTO of HRSD, the utility in Virginia, Norfolk. I think, well, different sites. But I think that person, was a big inspiration for me. That person not only has a vision, but not only brings his vision in practice. Because you have many people with vision, you only have few with a vision making it happen. That kind of person is a person like that, and I think he's an inspiration globally for many utilities. So I would definitely recommend you to interview Charles Bott and ask about all the great projects they are doing, including the SWIFT, which is the indirect potable reuse project.
So I'm going to reach out to him and hope that he'll accept the interview, because you just teased a very nice content. So I'm curious. So thanks a lot. So actually, thank you very much, Wim. I think it's the longest record I ever made, and I could make it last for another hour, but really, I'm sorry for that. I have to be cautious of your time at some point. So thanks a lot for being with us, and I hope to learn a lot during your upcoming conferences at WEFTEC and in the next ones.
Thank you very much, Antoine. It was a pleasure talking to you. I really enjoyed it.
Thanks for listening to Don't Waste Water. This podcast was brought to you by GF Piping Systems. Loved this episode? Head over to Apple Podcasts to subscribe, rate, and leave a review. See you next time.